Hi, welcome back to another Study with Me session. So today we're going to look at trigonometry again, but a slightly different area within trigonometry where we're going to focus on more problem solving or application of trigonometry. So how I sort of plan this session is we'll just be looking at some exam questions in this area, and we'll explore sort of different bits ranging from bearings to 3D trig. So the really typical exam questions in this area, there is a combination of both advanced 2-unit content here as well as extension 1. But let's get straight into it. I'm excited. Right. So before we look at problems, all right, let's go back to the basics. Let's go back to the fundamental formulas that you should be aware of, hopefully. So firstly, basic right angle trigonometry. I'm hoping at this stage we know sine, cos, tan, what they stand for. So let's say right angle triangle. The longer side is the hypotenuse. The side next to it is adjacent. The side opposite is opposite. Yeah. So remember SOHCAHTOA? Yeah. So I'm pretty sure you would have seen that in Year 9, Year 10. So sine is opposite over hypotenuse. Cosine, adjacent over hypotenuse. And tan, opposite over adjacent. All right, so I'm assuming you know the basic Fourier ratios at the least. And then you've got sine rule and the cosine rule. So the sine rule, it's a ratio. Let's call that ABC. It's a ratio between the side lengths and these angles. So sine A, so sine this angle on the opposite side should equal to sine B on B, sine C on C. And obviously the relationships can be flipped as well. Now they are all on the reference sheet, so you don't need to memorize any of these, just be aware of its existence. All right, I'll also quickly go over the cosine rule. So the cosine rule is actually the one we'll be using a lot of today, so cosine rule. Now I don't remember if you have both versions of the cosine rule in the reference sheet, but I'll give you both because they do have a different purpose depending on what you have. So basically the fact pattern that triggers the cosine rule is if you have an angle in between two sides, yeah, and you want to look for the third side, that's one version. So a square is equal to b squared plus c squared minus 2bc cos a. All right, so that's one. That's for finding a side. If you have an angle and the two adjacent sides. Or if you want to find the angle cos A, yeah, you can also use this formula, which is just a rearrangement of this formula really. So b squared plus c squared minus a squared onto bc. All right, so that's a brief overview. Let's go straight into the first problem. All right, so there's some basic right angle trigonometry here. So let's have a read of the question. So we've got the angle of elevation of this tree here from P is 10 degrees and 12 minutes. And then walk 100 meters, look it up again. It's now 14 degrees and 38 minutes. So what we're going to do is try to find the height of the tree. So let's call that H worth 3 marks. All right, so to start, what we're going to do is this, so planning out a little bit, right? I'm going to find this side first. Why? It's because if you look at PTQ, you can actually then link this side to that angle and then this side to that angle over there and use the sine rule to be able to figure out what H is. All right, so 3 steps. Let me just move that. All right, so step 1. I'm going to look at triangle TBQ. Triangle TBQ and look for TQ. Okay, so this is basic right angle trigonometry. Opposite over hypotenuse. So sine 1438 is equal to h on TQ. So TQ is equal to h on sine 1438. Yeah, so just these two basically cross multiply. All right, so first step. All right, so let me just note that down, right? So that's h on sine 1438. Okay, now I was planning to apply the sine rule, so let's investigate what we have. So we have that on and the opposite angle, so that's good. We have that, but we're missing the opposite angle, so we need to find this angle here. Okay, and it's actually pretty easy. Let's see if I can highlight it with a bit of yellow. So if you look at this triangle here, yeah, so that's basically the exterior angle, and those are the interior angles. So angle PTQ plus 10 degrees and 12 minutes should equal to 14 degrees and 38 minutes. That's the exterior angle of a triangle is always equal to the sum of the opposite interior angle. All right, so I won't write that down because I don't have space, but you know what I'm talking about. All right, so subtract that through. That should be 4 degrees and 26 minutes. All right, so then third step is to actually apply the sine rule. Okay, so TQ on the opposite angle, sine 10 degrees and 12 minutes is equal to 100 on sine 4 degrees and 26 minutes. All right, so that means TQ is equal to 100 times that. Now I might partially evaluate this just to save some space here. All right, so 100 sine 10, 12, sine 4, 26. Okay, so the right hand side, just chucked it into the calculator, is about 229.09, thereabouts. All right, TQ itself represents h on sine 1438. Okay, so I'm just going to continue up here where I have a bit more space. So h is equals to 229.09 times sine 1438, which is 50. Hold on a sec. Let me just make sure I got the. Yep, that's right. Right, so that should be 57.88, which is to the nearest centimeter. For meters, yeah, it's 2 decimal places, so that's pretty much it. All right, so that's it. I'm just going to double check my answer just in case. Yeah, and you should do that in any exam as well, because one of the most common silly mistakes is typing it wrong into the calculator. Let's see, 26. Okay. Yeah, 57.88. Yep, that's all checking out. Yeah, I'm just double checking because I picked up my own mistake. My written notes has a different answer. All right, that's pretty much it. So to summarize, right angle triangle, you've got sine, yes, sine 1438 is h over the hypotenuse, and then you get a value for TQ. We worked out this angle using exterior angle of a triangle, and we used the sine rule to link everything together. And TQ is from the first part, and then we just times that across, and that will get 57.88. All right, so let's have a look at the next one. This one, it's a bearing question. So what I'm finding is a lot of students do struggle with the concept of bearing. There's two parts to the struggle. First part is actually understanding the question itself. Yeah, when it says find the true bearing of C from A, what angle are you looking for? So I see a lot of confusion around that. And then the second thing is, well, how do you draw this? Like, what does the bearing actually mean? So I'm hoping this question will clarify things. So we've got A sails from a port A. Sorry, so a ship sails from a port A 50 due east to port B. So let's draw this thing. All right, so that's A, that's north. All right, sails east, so that direction to B for 50. And then it precedes a distance of 30 on a bearing of 20. So what a bearing of 20 actually means is from north, you go clockwise by 20 degrees, right, to get to C. And that distance is 30. So the question is, what is that distance? AC. That's the first part. All right, so let's call that, yeah, let's keep it as is, doesn't matter. All right, so that's 20 degrees. That's right angle. Okay, so that angle there is 90 plus 20, 110. Okay, and we have the perfect scenario to apply cosine rule because you've got two adjacent sides and the included angle. All right, so AC squared is equals to B squared. So actually, let me just write it up so you know what I'm talking about. Like, what is this BCA? All right, so B squared is 50, C squared is 30, 2B C cos A, 110. All right, so put that into the calculator. That should be 4426 square root. That should give you about 66.53 to 2 decimal places, nautical mile. All right, so that's it for the first part. And then the second part, true bearing. Now, this is important. How do you read this? C from A means from A, the direction to C. Yeah, from A, the direction to C. So in other words, you're looking for that angle there. That's what you're looking for. Okay, so to find that angle there, we need to figure out this angle first. So we're going to use the sine rule to help us build this. So I'm going to see if I can squeeze it down here. So 30, actually we're looking for angle, so I'm going to make angle go first. So sine theta on 30 is equal to, and we know this angle, so you want to use that side, so 66.53. Sine 110 on 66.53. All right, so sine theta is equal to 30 times sine 110 on 66.53. So sine theta is equal to, let's see the magic of our calculator, 66.53 gives you 0.424 and then you inverse sine that. It should be about 25 degrees. Yes, about 25 degrees. Right, so that's 25 degrees. So therefore, the bearing of C from A is this angle here, right? This angle here is 90 minus 25, which is 65. So 065, yeah? There should be 3 digits in the true bearing. All right, that's pretty much it. So to summarize, so first, you draw the bearings diagram so you know the relationship between your points. And then in this case, we use the bearing to help us find the angle, and then the cosine rule to apply to the information to find the third missing side. And then after that, it's just using the sine rule to find the angle we need and then turn that into a bearing. All right, so let's have a look at more advanced question. This one is actually from the HSC. It's a 2-unit question, but the way they've applied the cosine rule here is actually very interesting. And I find that whenever I give this, I thought in my mind, oh, this is really simple. But whenever I give this question out to my students, most people can't do it on the first go. So I thought that was very interesting. I think it's because the information you're given is not typical of what you get for a cosine rule. All right, so let's see how you apply this. So basically, this thing just kind of describes what is on the diagram, so I won't read it out. And you're trying to apply the cosine rule to link everything together. Now, the thing with cosine rule is this. A squared in the formula is always the side that's opposite the angle you have. Sorry, not A squared, A. Okay, opposite the angle you have. So naturally, B and C are the sides next to the angle you have. But what tripped up a lot of people is actually the sides next to it is X. So I think that confuses a lot of people, and there's this misconception, I then need to find that angle, which you actually don't. So let's see how we apply the cosine rule, right? So let's rewrite the formula out here. All right, so A is 22, B is 20, C is X, cos 60. All right, so that's the initial application. So 22 squared is 484. 20 squared is 400. And 20 times cos 60, which should be a half, is 20. Okay, and then I'm just going to move everything to one side. And that's it. All right, so that's how you create the quadratic. Now, like I was mentioning in some of my earlier videos, right? If you can't answer the first part, answer the second part. You've got a quadratic. How else are you going to find the distance from the lighthouse to the post office? Solve the equation. That's it. Yeah, easy 2 marks. If you can't get the 1, get the 2. Yeah, all right. So I'm just going to go to the next page so I have more room. So the second part is just literally solving the quadratic. So let me rewrite the quadratic. You don't even need to factorize it, just chuck it into the quadratic formula. 4AC over 2A. All right, and then usually I put that into the calculator first, so that's 736. And then putting 2 plus 736 on 2 into the calculator, it should be 23.56, and the other one should be negative 3.56. Okay, so I'll just double check just in case. 736 over 2. Yes, I think it checks out. Yes, I think it checks out. Okay, so usually there's a positive and negative answer, but X should be a positive answer. since it's a length. So therefore, x should equal to 23.56, and it says correct to the nearest kilometer, so I'll just round it up to 24 kilometers. All right, so that's basically it. So let's go back and have a look at the question again. So first of all, apply the cosine rule. Yeah, B and C are always the sides next to the angle you're looking at, and then you just create the equation from there. The second part is just solving the quadratic, eliminate the answer that's clearly wrong, and that's it. Alright, so let's have a look at 3D trig. So 3D trig is actually an interesting area because it used to be an extension 1 topic, and now you have to do elements of 3D trig in the advanced 2 unit course as well. So this question actually came from an extension paper, but it's definitely on the easier side. So hopefully for those 2 unit students out there, it's like, oh my god, I have to do 3D trig. This helps immensely, hopefully. Alright, so now, don't fear 3D trig. 3D trig is still trigonometry, but obviously the diagram is meant to be in 3D. But how you solve a lot of 3D trig questions is break it down into 2D diagrams. And to be honest, even I do that, you know, after teaching how many years, like 10, 15 years, I still break it down because that's how you make sure you capture all the information, you're not missing any relationships, and you're not making mistakes. Yeah, I see people make mistakes because they try to avoid breaking down the diagram, and I think in the end they actually lose out because they spend more time trying to figure out what is going on and trying to fix their errors. So I always recommend break it down. Okay, so basically in this question we are looking for the height, TO. Okay, there are 3 triangles here, TAO, TOB, so those are vertical, yeah, and on the horizontal plane, there's AOB, okay, so now these are actually right angle triangle. It doesn't look like it because this is a 2D representation of a 3D situation, so if I was to show you in real life, it would be 2 vertical things and 1 horizontal thing. Yeah, that's what it should look like. All right, so I'm going to draw them. You know what? I'll draw them on the next page just so that we have it in front of us as we attempt this. All right. All right, so you've got TAO, H, 45. Now, if you're finding these revision series very helpful, right? It's good to listen to me talk about problems, but I can tell you from my personal experience and just from teaching that many years, listening to someone, your knowledge is going to be probably retaining about 10%. I think some study have shown. I'll just make sure I've captured the right thing. So that's 160. Listening to me talking, you're going to retain 10%. Actually attempting to do this, yeah, so look at the question, attempt to do this, and then look at my explanation, you will probably retain 70%. Now, here's the one. Here's the kicker. If you listen to me, attempt the question, and then try to teach your friend, you retain 90%. Yeah, so there is a bit of a pyramid. I'm sure you may have seen this around knowledge retention. So always recommend you at least, you know, attempt these, right? It's gonna be boring listening to me talk, so attempt it yourself, and then things are just gonna make so much more sense. And then, you know, attempt it yourself, you know, sort of the areas you're like, oh, I don't fully understand that, then you can listen to my explanation and then try to make sense of it. And that's how you grow as a student and sort of gain that additional knowledge. All right, so let's summarize what I've done here. So I've captured this triangle here, which is this one here. I've captured this triangle here, which is this one here. And I've captured the bottom triangle here, which is this one here. Okay, so first step, you need to figure out this side, which links up with this side. Okay, very easy. Basic right angle trigonometry. Tan 45 is H on AO. Tan 45 is 1. Or you might even know this. If it's a right angle triangle with a 45-degree angle, it's an isosceles right angle triangle. Okay, so AO is H. So this is H. This is H. Remember, they are the same side. They are this side, right? It's a shared side between the two triangles. All right, so we're going to do the same thing on the other one. Tan 30 is equals to H on OB. Tan 30 is 1 on root 3. Cross multiply. Okay, so I'll use a different color. So this one is this one, which is root 3H, root 3H. Now come back to the diagram. That's the side I'm talking about. It's a shared side. Yeah, so they are the same thing. All right, so once you've worked on the shared sides, so that's always your starting point. Look at the right angle triangles, work out the shared sides. Yeah, and then link it all together on the bottom using cosine rule usually. And this is actually, now that I followed the previous one, we should be able to work out how to apply the cosine rule. So remember, with cosine rule, the opposite side is always A. Okay, and then these are B's and C's when it comes to applying the formula, right? So A squared is B squared plus C squared 2BC cos A. All right, so let's do this. All right, A is root 3H. B is H. C is 100. 2BC cos 60. All right, so that's 3H squared, H squared. I'll leave that as 100 squared. 2 times 100 times cos 60. Cos 60 is a half, so it's 100H. Move everything to the left side. That's 2H squared plus 100H minus 100 squared. Now, if you're feeling a little bit lazy like me, I think that you can probably factorize this thing. Based on the answer, you can. But if you're lazy, just chuck it into the quadratic formula. So I'm just going to roll it off here. I'm going to move my face there. All right, quadratic minus B plus minus B squared 4AC over 2A. Alright, so just like before, I like to partially evaluate this. It just makes it easier to put into the calculator. So that should be 90,000. Okay, and then you put that into the calculator again. So do the plus and minus components separately. Alright, so the first one is 50. And the second one is minus 100. Alright, so obviously it shouldn't be minus 100 because H is a height. So, sorry, I'm like kind of working in like a circle here. So since H is a positive answer, therefore H is equals to 50 meters. And that's it. Alright, so just to summarize, right? First, you draw out the 2D triangles like what I've done here, yeah? 3 triangles from the previous question. Yeah, so 1, 2, 3. And then you work out the common sides, put that into the bottom triangle, which has all the information with lengths and angles. And then cosine rule, link it together, solve the equation. In this case, we've got 2 answers. You just filter it, get rid of the answer that doesn't make sense, quote the answer that makes sense. All right, so that's it. That's to show you how to attempt a 3D trig question. Now, for my extension 1 friends, I've got a hectic one for you here. So this is still 3D trig. So if you're a 2-unit student, you want to challenge yourself, feel free to stay on this video and just watch it to the end, because I think this one is actually very, very good. Not only is it a 3D trig question, so sometimes the more advanced trigonometry questions are proving identities. Yeah, they say, oh, show you on the diagram, blah, 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 that's the relationship. Show me, like this guy, show me cos theta is that thing. Yeah, show me a relationship. And you have to figure out from the diagram, where are these relationships coming from? Yeah, you need to link things together. And I think that's the challenge in a lot of these questions. All right, so let's have a look at how this one works. So this is all in radians, but I'll convert it in degrees. So that's 45 and that's 60. Yeah, just easier for us to work with. Basically, what's been described here is what you see on the diagram. So we're going to start by breaking up. We've got 4 triangles here. 1, 2, bottom one, and this one on the side as well. Now, normally I won't consider this one, but you've got an angle sitting in that triangle. So that's sort of like a hint, look at that triangle too. All right, so let's do that over the next page. And then I'll draw all of them. That's all right. Just get it out of the way in one go. And then the bottom one, AOB. Now, if you find that you're struggling to see how all of these things work, it's not you. I find that a lot of students struggle with that, so don't feel like you're alone. I generally find that students who have a very strong spatial awareness are able to do 3D trig without any issues at all. Those who are not so strong on spatial awareness, so those people who are likely to drive a car and crash it potentially, they are probably less so. Yeah, they do struggle to see what this 3D diagram is supposed to look like. And to be honest, I think it's something you can practice. I mean, naturally you might have a weaker ability, but definitely can come with practice, right? You just systemize your approach. So when you see it, you're like, okay, I need to spit out these 2D triangles like what I'm doing, and then just focus on the 2D triangles, which you can sort of wrap your head around. All right. So let me just link the triangles for you so you're not like, what are these triangles for? All right, so the first one, 45 degrees, AOP. This is the alpha angle, POB, POB. APB is that one with the theta angle, that one there. And the bottom one, AOB, has a 60-degree angle, 60-degree angle. All right, so let's have a look at what we need to prove here. We need to find AB, or show AB squared is that. Now, if you look at the expression here, notice there's a cos theta. So it means that we are looking at PAB, and actually the question tells you look at triangle PAB. All right, so that's where we're going to look for it. So let's work with these 3 triangles first. Again, I'm going to highlight the sides. I'm going to work out. So AO, actually I don't want to work out AO. I want to work out AP. Wrong one. Okay, AP. Yeah, because that's the shared side. And then PB. PB. All right, I'm going to work out those components. So let's start with this one here. So what's that sine? Is H on AP, 1 on root 2, H on AP. AP is root 2h. Okay, so that's root 2h. This one here, same thing, sine h on pb. pb is h on sine alpha, which is, I'm also converting now, cosec alpha. Alright, h cosec alpha. Alright, so then from here, we are going to find AB squared. So I'm going to link everything together using the cosine rule. So A squared plus B squared equals to B squared plus C squared minus 2BC cos A. Alright, so remember, A is that side, the side opposite the angle. The others are B and C. Alright, let's do this. So AB squared is equal to root 2h squared, h cosec alpha squared minus 2 times root 2h h cosec alpha cos theta. Okay, now if you compare this to what we're trying to prove, is actually the same thing now, right? I'll just clean it up so it looks like the question. So AB squared is equals to 2h squared h squared cosec alpha squared 2 root 2h squared cosec alpha cos theta. That's it. Alright, nice and easy piece of cake. Alright, so let's see if I can duplicate this. I don't know if I can. Anyways, I'll just go to the next page and then see if I can copy this across, just so that we have the diagrams. Aha, so that worked. Okay, yes, because I need the diagrams, right? Okay, so I'm gonna just tidy that up a little bit. Nope, I can't tidy it up. Leave it alone. Okay. All right, so let's go and have a look at the second part, right? So the second part, hence show cos theta is equal to that 2 marks. So it's not worth a lot of marks, but mind you, this is probably the last question of an exam paper, so it's not meant to be worth a lot and requires a lot of problem solving and figuring out what to do. All right, so let's think. You've got AB squared using this triangle here. We haven't used the bottom triangle AOB, and that's got a different piece of information. So let's start with that. Let's look at the bottom triangle first, right? Because we can also get AB squared by looking at the bottom triangle. Okay, so if we're going to look at the bottom triangle, so this time we are going to, just realize that's not in the right place. One sec. So, sorry, I just realized I put that into the wrong place. I was like, no, but that's not root 2h, that one's root 2h. Right, that's better. Okay. Alright, so this time we need to look for that side. I might see if I can use different colors. So let's see this side. Okay, AO is this side. So that's tan 45 is equals to H on AO. Tan 45 is 1. AO is H. So that's H. H. Okay, so same with this one. We want to look for this one here. Okay, so this one here. So this time it's tan alpha is equals to H on OB. So OB is H on tan alpha, H cot alpha, H cot alpha. Now our objective here is to use the cosine rule again. and link everything together. All right, so AB square is equals to H square, H cot alpha square, 2H cot alpha cos 60 So the 2 and cos 60 are going to cancel out. The 2 times a half. So you just H squared cot alpha. All right, that's it. All right, so let's think about what we've got so far. We've got two expressions. AB squared is equal to that from the first part. And AB squared is equal to that. So naturally, I know the question was to find cos theta, but it's pretty obvious you'll have to link them together to create cos theta, and cos theta is in the first expression. All right, so we're going to equate the two AB squared expressions. So I'm just going to copy them across first. And then the second part, we've shown that AB squared is also equal to that. Okay, so I'm going to equate these guys, all right? So H squared cot alpha squared All right, so that's our first step. Now first, I'm going to clean out all the H squared. So you see there's H squared in every single term. So I'm just going to divide everything by H squared. Yeah, that should clean it very nicely. So it's irrelevant what H is, in other words. So that's 1. All right, so from here, you're looking for cos theta, right? So you will have to make that the subject. But before I do that, now, you may or may not remember this, but 1 plus cot square, it's an identity, and it's equal to cosec square. Okay, so that's an identity. I think it might not be on the reference sheet, but you get it from the very basic Pythagorean identity that sine square plus cos square is 1. All right, so we're going to replace that with cosec. Okay, so they end up cancelling. Yeah, it's on both sides. All right, what I'm going to do is I'm going to move this term across to the left side. And I'm going to move the cot theta to the cot alpha to the other side. All right, so now the final answer is meant to have sine and cosine. So what I'm going to do next is make the ratios in terms of sine and cos. So 2 root 2 cos theta over, so cosec is 1 on sine, so that's sine alpha. This guy here is cos alpha on sine alpha. Okay, so then from here, I'm going to make this one fraction. Okay, so if you're wondering how I made it one fraction, so you need a common denominator, right? So times that by sine alpha on sine alpha. Yeah? All right, so then from here, so I'm just going to go to the next page. Alright, so I'm just copying the previous step just so that we have it in front of us. Okay, then the next step is I'm going to multiply these guys across, right? So multiply the sine alpha on top and 2 root 2 on the bottom. They cancel. And I'm going to rationalize so that's root 2 on 4, 2 sine alpha plus cos alpha. That's it. All right, so that was the last one, very challenging. So it's just teasing out whether you, not only whether you know your trigonometry, this is a problem solving question, whether you're able to link different bits together. All right, so to summarize. So your first step is 3D trig question, draw out the 2D triangles. All right, and then you just use the guidance they've given you in the question. Look at PAB and try to create that expression. So that's what we've done here, yeah? We looked at this side and then link them together using the cosine rule. Right, so I might as well clean up our working a little bit so you can see the linkages. All right, so that's the first step. So the second step is to kind of do the same thing. So that was meant to be h cosec alpha, and this one we worked it out to be h cot alpha. Okay, so same thing on the second one, you work with this side as well as this side, which corresponds with AO and BO, cosine rule, you get another expression for B squared. And then you get the two expressions for AB squared, equate them in this step, all the h squared divided through, so they all disappear. And using the identity, 1 plus cot alpha squared is cosec alpha squared to change that, so they cancel out. So you're left with this guy here. And then you just change the cosec alpha and the cot alpha into cos on sine and 1 on sine for that one. And then you just rearrange, clean it up, and then you get to the expression. All right, so that is pretty much it. All right. So thank you for watching once again. Hopefully you found it helpful. So these videos, the Study With Me series is my attempt to help a lot of year 11 students who may be struggling with the content a little bit wrap our head around the critical concepts. Now, I am not covering every single thing because I think there are certain elements that's going to come up in exams time and time again. So that's kind of been where I've been focusing on. But if you have any specific topics you want me to cover, leave a comment down below, or you can contact us on Facebook page, email, website. All right, any of those avenues, you should be able to reach me. And best of luck. That's it for today. Bye for now.